So here's a dainty thing. This is a Rotel RB-1590 power amplifier, and it powers up okay. You go through the routine here, and you can hear the relays clicking there, and then you get a solid light, so it all looks good. However, the left channel is out, the left channel's dead, and the owner said there was some fuses on that he replaced, and then they just blew again. So we're expecting some output transistor failures there, and it really is a bit of a monster really. We've got dual mono amps, and you can see the transformer here, but there's another transformer underneath that. There's a kind of steel plate under this one, and another transformer for the other channel there, and then this huge lump here, this is our reservoir capacitors here. So a huge bank of reservoir capacitors there, and then the two power amp modules. And I'm hoping that these will just sort of unscrew, and we can get this power amp module out fairly readily to see what's going on. And in fact, I mean, we can see what's going on right away really. You know, when you hear the story about the fuses blown, we're expecting output transistors to be short, and if we quickly buzz here, we've got a dead short, all pins to all pins, and all these transistors are all going to be in parallel, and there'll be another set at the bottom side of the heatsink. So we're kind of clear about what's gone wrong. So the next stage now, we'll get this module out and just have a closer look and see if we can kind of narrow things down. Hopefully not all of these transistors are gone. We might be lucky, and just one or two of them that we need to deal with, but let's get that out and we'll see where we are. Alright, it's got a whole bunch of screws and hidden cables to get to this thing, but I've got it free now. And actually, when I was putting my hand down in here, there's some residue of something. So there's maybe been a capacitor or something going here, but there's some liquid electrolyte or whatever going on there. But power amp is free now, so I mean, there was a bunch of awkward cables there, but we're free. Oh yeah, you can see there we've got where's that yet? So we've got some damage has been done here. This capacitor's gone, the top's domed, so that's upset itself, and you know, maybe that's not going to be the cause of our problems, I don't think, but we'll see. It's maybe been a secondary issue, but let's get in a bit closer and we'll see. That would be great if that's the root cause. Right, so we'll get this module on the bench now, get rid of some of this bulk, and see if we can focus on what's going on. Here we are then. This is a bit more manageable, and we can clearly see when we open it up, or when we get the board out here, this capacitor's just lost its head. So we'll deal with that, but I think we've really got some output transistor issues. We've got 6 sets of output transistors, positive and negative, and then these ones here are the drivers, and of course these are all obsolete. This amplifier is still in production, so they must be changing to some other variant of transistor. These are nice Sanken transistors, but that's the deal. They're all increasingly, these guys seem to be going obsolete. Anyway, if we measure sort of a collector to emitter on some of these transistors, they're these are all looking fairly bad. 0.1 ohm. That 0.1 ohm is just my cable resistance there. So these are all dead short. These 3 here seem to have a little bit more hope. They're up about 0.55, and of course they're in parallel, so these 3 here are reading that. On the other side, they're all reading the short. We could be misleading ourselves, of course, because everything's all in parallel, and don't know what funny effects we're going to see. So I think the next step is we need to remove these transistors from the board, and we need to get the board out as well, so we can replace that capacitor. So let's more screws to come away here, and we'll resume then. Right, we've got all these transistors out, and they're all short apart from these three. These three are reading okay, but these guys are every pin, they're all short. And on it goes. Just measure some of these here. So that's reading all right. So these three are fine. These other guys are all dead. The drivers seem okay. They check out all right. I can see that we've got some drive resistors for the main transistors here, and some of them are going a bit high. They're supposed to be 4.7. And then there, that guy's, it's obviously had a bit of a hard time, and its resistance is creeping up, so we'll need to change all these as well. But as I mentioned, these transistors are all obsolete, so we need to find some replacement that's going to do the job. So we'll go and do some searching there and come back. So I was rummaging around to see if we could see what Rotel are using nowadays in this amplifier, given that it's still in production. And we go to their web page here, and we get some nice internal pictures there. And what's interesting here though is that this shows 4 transistors on each channel here. Very different to us. We've got 6 and a very different physical transistor as well. And when we look down here, we've even got, we can get the part number here, 2SC3264. And these guys actually went obsolete before the ones we've got went obsolete. So I'm guessing this is just an old picture that they're still using on their web page here. And it's kind of bizarre that we've changed internals so much, but yet there's not been a product revision. So curious. So we're still stuck. We need to find some alternative, and we've got the usual suspects from onsemi or the like. However, I think I'm going to be looking at these Toshiba transistors, the 5200 and its complement. And when we kind of rummage around here and we look at we've got this nice, reasonably flat gain profile over the output current range. And most of the other specs are kind of fitting the bill as well. So we'll get some of these ordered up and see how we get on with them. All right, we've got our bunch of parts arrived here to start dealing with this board, and so we'll get on with that. We'll replace these caps, obviously. Some of these low level caps here are kind of dry, so we'll deal with all of them. Replace the base drive resistors for the power transistors, and that should clean things up. We've obviously got a bunch of new power transistors as well to deal with. So that's all fine. Looking at the board though, I'm not overly inspired by it. It's a fairly sort of run-of-the-mill type of circuitry here. We've got our input coming in on this shielded cable here, and then this is it's just a kind of basic electrolytic capacitor that's coupling that into our input stage. Input stage is transistors that are enclosed in this sort of must be heat shrink of some description, and there's some heat sink compound in there, and that's just to thermally tie the transistors in there. So this is our input section, move through to the gain section, and then this is the current source and sink that drives our bias and also the drive to the pre-output drive transistors, which are these guys here. So these two guys then drive the drivers, these two, and then they drive the 6 output transistors. That's all in parallel via these emitter resistors. And the fact these resistors are there, that's how we were able to measure and determine what transistors were gone even before we took them off the board. So fairly, as I say, not an overly inspiring piece of circuitry. When you look at the price point and you look at the sort of bulk of this thing, it's just pure grunt that they've sort of paralleled up all these transistors. This bit of circuitry here is just a bit of DC protection and sort of a timer to control this relay which connects our loudspeakers. So just make sure there's no DC on there. that's going to destroy our loudspeakers. So that's fairly sensible, but fairly basic. And the other thing that's fairly basic is this circuitry here. We've got the same circuitry on the positive and negative rails. This is our current limit. And obviously it's failed. You know, it's not done its job here. We've blown all these transistors. And it's a bit disappointing, you know, when you've got, as I say, an amplifier at this price point, and you know, something goes wrong and just all your transistors just blow. It's a bit so yeah, and even the quality of the board, I'm not even sure this is FR4. It might be, but it's not the best quality in the world. And then when I look at the soldering on the back, they're all kind of dull. All the joints are kind of dull and rubbish. So we'll maybe have to kind of deal with some of that. But let's get on. We'll get these caps removed, get them replaced, and start to sort of make some progress there. Right then, we've got our board recapped and installed back in the heatsink here. I've put the drivers back in. And one thing I discovered when I was looking at the board that I failed to check earlier on actually is all these emitter resistors on the last 3 transistors. These are all open, or they're very high resistance. They're supposed to be 0.22 ohms and some significant power here. This is maybe a 5 watt or a 7 watt resistor, and they've blown open. So I kind of, you know, looking at the size of them, that's surprising, but there you go. That's what's happened before the fuses have gone. So we'll have to order these up, but it's not going to hold us back. What we'll do is we'll just install a single transistor, and then we'll try and power up this board from a bench power supply and make sure everything's all right there before we start to parallel up the transistors. So that's my next move, is to get the output transistors in, or one set of them. And if we look at the original, we've got quite a nice profile here, just a bit of stress relief as it's mounted to the board. So we'll duplicate that, get our transistors in, and then we'll get some bench power on this and see where that takes us. Alright then, so I've got one set of output transistors loaded on the board here. So that's this pair here, and this is the sort of bias transistor here, just sensing the temperature. So that's all set up, and I'm connected to a bench supply as well, so we're kind of monitoring the current, and we've got control over the voltage. And I've only got a 50 volt rail on this, plus or minus 50 volts. Actually in the amp it's near 100 volts, which is quite ridiculous really, but that's where they're placing it. So our currents seem fine, and that's, you know, a good sign for moving forward. And I've got a signal on the input here, and if I can turn up the volume, we're obviously working just fine here. There's no load or anything like that, and obviously just the one set of transistors, but kind of tells us that everything else on this board is behaving as we expect, and so we're kind of good now to parallel up all these transistors and get our replacement resistors in place. So when these resistors arrive, we'll come back to this and deal with that. In the meantime, there's some other boards in the amp that we can pay attention to. You know, we'll recap the other channel, and then there's some sort of standby power supply and soft start and things. There's a board there for that. So let's go and have a look at that, and we'll see what we can do. Okay then, so looking inside the main unit again, and this is the board I'm talking about here. This is our standby supply. And then we can see there's this huge big resistor here, and this is going to be a soft start. You know, when we've got all this big capacitor bank here, it's a huge inrush, you know, when you first turn this thing on and start to charge these things up. So what's happening is we've got a series resistor that's going to be in series with these power transformers, and then once the capacitors charge up to some level or other, these relays will bypass that resistor and give it the full deal. So that's what this board is doing. And we've got some capacitors in here I've measured, and then they're kind of dry, so we'll deal with them. I don't know what's all going on in this board. There's a whole bunch of transistors and stuff in there as well, but we'll deal with these caps. One other interesting thing I see is that down here we've got this little flap thing here, And underneath we've got two bridge rectifiers. Kind of hard to see in the camera there, but there's two bridge rectifiers bolted to the base of the unit. But there's only two wires going to the whole thing, and so you wonder what that's about. And what's happening here is that these bridge rectifiers are in series with the mains coming in, and they're in anti-parallel. And what this is the purpose of this is to, if there's any sort of DC offset on the mains, what can happen is that these transformers start to get a bit upset and they start to hum quite severely. Quite a common problem with toroidal transformers, and the bigger they get, the bigger the problem. So these diodes just make sure that there's no, if there's a DC offset, the diodes are simply just not going to turn on, and it keeps things quiet. So this is what you'll see this spoken about as a DC blocker. You can sort of get little modules that do this as well, but that's all it is. It's just back-to-back diodes in series with the mains to kill any offset. So we'll get this board out, get these caps replaced, and then say the other thing is we'll recap that board, and by that time hopefully we're in a position to get our other parts on this board here and proceed with that. Alright, here we are a while later, and we've got all the transistors in, and they've replaced all of these emitter current sharing resistors. And it's powered up, got a plus and minus 50 volt bench supply as we had before, and it's working fine. You've got the bias adjustment down here, and then this is a DC offset adjustment. So I've turned the bias down to a fairly minimal level, just maybe about 5 milliamps per transistor pair, because I don't know what the final bias is meant to be, and when we put it on the full supply in the amp, we just don't know what's going to happen. So kind of cutting that right back now, and what we'll do is when we get it in the amp, we'll measure the other channel. We'll just measure the bias on that and then come up with some number to set this. So we're ready to put this in the amp now, so let's move on with that. Alright, the next step then, we've got the module just loosely assembled in the amp here, and it's wired up. We've got the power on it, we've got the speakers connected, or the speaker terminals connected anyway. So that's fine. However, when you're turning something like this on for the first time and you've got such a huge power reserve here, the chances is something, if there's something just not quite right, then you're just going to blow everything up again, and that it's never a good day when that happens. So what I've done here, I usually, with some of the Cyrus amps, I put a series resistor instead of the fuse, and that kind of helps you protect things as you turn it on. What I've done here is I've got a couple of light bulbs soldered across some dead fuses, and then the fuses are in there. So these are going to act as current limiters, if anything is not quite right, and hopefully save us, save us from blowing another set of transistors, etc. And I've got my DMM here. I'm just measuring across one of these emitter resistors so we can get an idea what sort of bias currents are flowing. And let's go and power it up then. And that's quite healthy. We saw a bit of a burst in the bulbs there as they came on. That's these big caps on the board charging up, and some of the other residual currents going on, and they've settled down. We've got a slight glow in both of them, so the amp is pulling a bit of current, and our bias is kind of creeping up there. It's settled about the 0.9 millivolt before, which is very low for what we're doing, just to keep things gentle at this stage. So I'm just going to let this settle now. We'll let this settle for a while, and then the next step is to remove the bulbs, put the fuses in, and then we'll kind of tweak our bias and make some final measurements. So we'll leave that for a while, and then we'll come back with the fuses in, see how we're doing. Right then, we're all got our amp fully installed, proper fuses, all the rest of it, so it's all under its own steam. Been running it for some hours, and it's very stable, so I'm quite comfortable we're all okay. and I've measured the bias currents on the right channel here, the original channel that was okay, and then dialed up similar numbers on the left. So when I look at it on the right, the bias actually varies between sort of 16 and 26 milliamps, depending on what transistor pair you're looking at. And when I get to the left channel set up, it's running between 26 and 22. So our spread's a little bit tighter on our refurb channel, so quite happy with that. So we're in good shape. We'll go and make a bunch of measurements now. I'll show a few of them, and then we're ready for wrapping up really. Alright, let's take a look at some measurements here, and this is with the input terminated, output into 8 ohms, and we're just measuring the noise floor in that. So it's a nice flat noise floor. Levels maybe averaging about 100, 115, 16, something like that. Got quite a lot of spurious going on here, which is a bit kind of unattractive, but I guess that's where it is. And both channels are the same, obviously, when we look at that. If I switch on the other channel, some of these 50 Hertz and 100 Hertz, etc. harmonics, some of them are a little bit lower, some of them are a little bit higher, and I guess this is just down to the position of the different boards in the actual amplifier itself. But both comparable, both got this kind of yucky, spiky floor, but the floor itself is a decent level. So let's go and we'll just stuff out some more power and see what kind of distortion numbers we get from this. Now my load here is only really good for 100 watts, so I can't really exercise this amp to its limit, nowhere near it. We can push things a little bit harder for a short period, and let's see what happens there. So if I turn my signal on there, 155 watts without a blink, our noise floor is pretty much as it was, and you can see the second harmonic there is down about 100 dB down on the fundamental. Really very, very good. Let's then we'll go and look at some distortion numbers. Alright, same measurement then, and let's just look at the distortion here when we turn this thing on. So we know we've got 155 watts, and I've got 0.002%, which is pretty incredible for that kind of power level. That's about 95, minus 95, so really superb. And this is the benefit of paralleling up all these transistors. You get these really low distortion numbers even at higher powers. So we're really in good shape here, and I think we're pretty well done. Time for a listen now, I think. Alright, here's our Rotel RB-1590 all back together, and a bit of a marathon this one. Just given the size and weight of this thing, just handling it's a bit of a challenge. And then of course we had to find our alternative transistors and gently work our way through that and turn it on slowly, just making sure we weren't going to do anything catastrophic again. But all very stable now, working fine, and I have been listening to this for a wee while, and it's one of these ones that catches your attention quite instantly really. The vocals really kind of jumped out at me, so I'm going to enjoy listening to this for a little bit longer before we hand it back, but let's just turn up the volume for now.
I like the way you tied the bow on your apron. These little things you never knew I watched.